Today's my topic is about heterogeneous hybrid distributed training helps the development of large-scale language model. I'm Lei Huang from China Mobile. Okay, thanks. Oops. As you know that with the development of large-scale models, we need to use many kinds of heterogeneous clusters like GPU, NPU, etc. to help us to do the model. And currently, as we all know, the source wall between different AI computing accelerators make it difficult to build one heterogeneous resource pool for large-scale models training. Heterogeneous hybrid distributed training becomes a pressing challenge for the industry to solve. We have summarized some challenges here to deal with. The first one is inhomogeneous task distribution. As we know that currently the distributed AI framework allocate tasks for homogeneous clusters by evenly splitting data or models. But for the heterogeneous clusters, which are different in computing capabilities, memories, bandwidth, and connectivities, so modifying this framework poses a key technical challenge. And the second one is about the strategy generation challenge, because as we know that the current inhomogeneous task distribution is very hard to do, so that is also very hard to find a good performance for the heterogeneous training. So we have proposed this big challenge to do the prediction work. The third one is training execution challenge, because it is we are now that use inconsistent computing and communication interface, so that how to find a unified standard for the communication is also a very important work. For the reason of large-scale model training, so that we have bring up the technology named heterogeneous hybrid distributed training. And here it is the architecture of our technology, and in the right side is the three key technologies of our work. As we can see that in this page, the first key technology we have proposed is heterogeneous training task splitting. In this work, in homogeneous task distribution, to achieve heterogeneous computing capability, differential perception, and multi-strategy decomposition and matching of single training tasks in heterogeneous clusters. And the second key technology is heterogeneous training performance prediction. In this one, we build performance prediction tool for heterogeneous hybrid training to achieve automated generation of optimal distributed training strategies. And the three key technology is the work of unified communication. In this one, we can achieve a task distribution and data transmission mechanism include weight, gradient optimizer update in a mixed heterogeneous environment, and we can achieve communication between different chips or different accelerators. And let me try to introduce each of the key technologies for you. In the first one, we bring up these key technologies for the reason that due to the complexity of computational resource in heterogeneous clusters, resource isolation needs to be implemented based on the computing capability of cluster, and the framework layer should also add the capability for inhomogeneous task distribution. And so for that, for the problem here, so that we have bring up the solution here to solve this, it is so that by evaluating the computation requirements of different layers of the neural network, we allocate subclusters with corresponding computing capabilities based on the computational demands of divided subnetwork. Thereby, so we are achieving load balancing. This work supports mainstream parallel strategies such as data parallel and pipeline parallel. As shown here, this one is the code example of our framework. And you can see that we can choose the mixed mode of our parallelism, so that we can choose to do the heterogeneous DP or heterogeneous PP. If we choose heterogeneous DP here, for example, so that we can set the different macro batch size and macro batch numbers here to split the task in different computing resources. Second one is performance prediction tool. Here comes the problem is how to minimize the computing capability of various heterogeneous hardware resources and achieve best ITD. It is as already introduced before. ITD performance requires introducing a mechanism for projecting parallel partitioning strategy performance. So here we have bring up also a solution here. We think that represent and divide multiple complex hybrid strategy, parallel strategy through a theoretical strategy tree, and then we will simulate the distributed parallel training execution strategy via a hierarchical topology-aware executor. This obtains parameters such as training, simulation, throughput, the CPU node computation time, and the GPU communication time, and also comprehensively analyzes them to derive the optimal non-uniform partitioning strategy. How about the hybrid communication? We also have already done a lot of job here. The reason why we do this job is that we come across the problem that the different hardware communication protocols varies, and using a single vendor's communication library is unable to achieve information transmission and parameter synchronization between heterogeneous hardware. So that to build a data transmission coordination mechanism between different training tasks, address the differences in communication interfaces, protocols, and topology among intelligent computing chips from different vendors. We design a standard constraint for multiple recognition among multiple vendors. Here, this is the work we have done, that the standards we have defined. We have defined a unified API, a data format, and also unified communication process constraints. Indeed, we have also do many verification work. We have do verification work in a cluster of NVIDIA H100. We use 3 nodes of this, and also another accelerator, AI accelerator, named VI-V-S. And we use 3 nodes here to combine heterogeneous clusters. The communication library here, we respectively use Nickel and ITACCL for the different AI accelerators. And the metrics here to value the results of our verification, here we use throughput and speed up. And as shown here, our speed up has greater than 92%, and also our loss can down to nearly 3. And also we have do the PPL here, that it can be reached to like, for example, like in Wikitext 2, it can reach to 18. In open source, we plan to build open source heterogeneous hybrid training unified communication ecosystem. In this ecosystem, we will define a unified C0 API. And also, we want all of you to collaborate with us to define data format and also the process constraints, because you know that we need all vendors to come to our projects to do this together. Okay, thank you everyone. If you would like to also, another thing about our work is that our work is in the CFN work group under the OIF. So if you have the interest, you can try to join us our group, and then we can work together. Thank you everyone.